I'm ready to go. Start it.
I press the button.
Okay, so the feature that we are standing on here is called a drumlin. Hopefully that's a term that you're familiar with. You should have heard it in the lecture last week. This is stop 1 and stop 2 on your landform field trips notes. So we're actually going to take a look at two different features and think about two different types of glacial processes while we're here. So while you're walking up the hill, what did you notice about the material that you saw in the outcrop? Was it angular or was it rounded? Angular material. And what about the grain size? Did it appear to have a pretty broad range of particle sizes, or was it a fairly narrow range? Did it have fine-grained and coarse-grained, or was it just one or two different grain sizes? It had a fairly broad range of particle sizes. So that's very typical of a drumlin. That's what you would expect to see within this if we excavated it. Angular material with a range of sizes. The sizes actually range from very fine grained to clay-sized particles all the way through to boulder-sized particles. Now if you think about that in terms of grading, which is an engineering term, and sorting, which is a geological term, would you describe that material as well graded or as poorly graded?
Poorly graded?
We got poorly graded down here. Do we have anything up here? It's actually well graded. For engineering purposes, it's good to have material with a range of grain sizes. So when we think about material that is well graded, it is graded from small particles to large particles. Now geologists prefer things a bit more neat, and we would consider it to be poorly sorted. So it's essentially a random accumulation of a bunch of different grain sizes, so it has not been sorted at all. So this material that you see in this drumlin is well graded and poorly sorted. So in your notes here, where it says internal makeup and origin, make sure that you've got some notes in there that have those kinds of words in it. And at the bottom you have some keywords, so we're going to put these into our list. What is the term that is used to describe any kind of material that was deposited by a glacier? Do you remember from last week?
Debris.
It is debris, but it has a specific name. I thought I heard it back there somewhere.
Till.
Till. Glacial till. So this is a feature that has been made by glacial till. Does anybody recall how it was created? How do you actually make a drumlin? Yep. So
the ice?
it is.
Yeah.
It is formed by the ice.
As the ice slowly recedes, it'll just keep dropping massive boulders, and as the glacier stays still, boulders will be pushed to the end, dropped off, and then new boulders will be
That is a glacial feature. That's actually something called a moraine, which we'll look at a little bit later. What we're actually looking at here is a feature that was created by ice that was advancing, and it was bulldozing over pre-existing till. Now the base of the ice sheet is not smooth. It has humps and divots and fluctuations in it, and as it rides over the top of till that has been laid down previously by another glacier, it actually sculpts it into what we call fluted terrain. So in this area, there is something in the vicinity of 3,000 drumlins, and they're all oriented in approximately the same direction. So they're all oriented northeast to southwest, and the shape of the drumlin and the direction can give us an indication of the direction of ice flow. So do you remember how we can tell in which direction the ice flowed? It's based on the shape of the drumlin. Yep.
The way that it recedes backwards, so it would be
it's flowing the opposite direction of it?
You're on the right track. Does anybody else want to have a stab? Yep.
The more gradual side is where it came from, and then the drop off is.
Like
Okay,
in time.
it's actually the opposite way around. So, when we think of the shape of a drumlin, it's like an upside down spoon. So you have a steep end, which is called the stoss, and you have a more gently sloping end, which is called the lee. Now, the stoss, which is the steep end, is actually up ice. You can't really see it particularly well here, but in this case, the stoss is behind me. The lee is in that direction, and when we leave in the bus and go around the corner, you're actually going to be able to see that fairly gently sloping side. So if that's the stoss, if that's the steep end, and that's the lee, which way was the ice moving forward? That's the stoss, that's the lee. Yep, it was moving in that direction. Okay, so these are features that have been overridden by about 3 kilometers of ice. What do you think happens to material that has been squashed by 3 kilometers of ice? Do you think it gets compressed and consolidated, or is it still going to be quite loose and friable?
Compressed and consolidated?
It's going to be compressed and consolidated. So we end up with material in this drumlin that is very dense. Now that has some implications for drainage, both across the top of it and within the drumlin. So if we consider surface drainage at first, do you think surface drainage is going to be good or is it going to be poor?
Good.
Going to be good. How come?
Right.
Yeah, so the material in here is all compressed. It's going to be very hard for any kind of moisture to percolate down through that compressed material. So we've got very good surface drainage. What about drainage within the drumlin?
Poor.
So we've got compressed material, we've got lots of clay-sized particles, not much interconnected porosity. Good or poor internal drainage?
Poor.
It's going to be pretty poor. Okay, so aerial extent. This particular drumlin field extends from Lindsay to Peterborough and contains about 3,000 drumlins, and you can see it very nicely if you look on a geological map, or if you look on Google Earth. You can see this lineated terrain or fluted terrain. It is composed of drift or angular till, which has been dropped by the ice, and you can see that in the feature behind you. Is this an ice contact feature or is it a water contact feature? It's an ice contact feature. Yep, for sure. Now the only other thing that we want to kind of think about is the types of vegetation that is going to grow on these types of features. It's a little bit difficult to see on this one. This one is actually part of farmland. It's turned into pasture now. But if you have a look at some of the high points around us, what kind of trees do you see growing on them? And I just need a general description.
Little shrub.
Little shrubs, but if you look a bit further over there onto that high point there, what kind of trees are those?
Pretty much all deciduous.
They're pretty much all deciduous. They're mostly hardwood trees. And that's because soil profiles on these glacial features here on drumlins develop quite nicely. You know, water flows off the surface, some of it infiltrates, it doesn't disappear particularly quickly, and so we get a nice thick soil profile that supports those hardwood trees, which require quite a bit of water and some pretty significant nutrients. Okay, the other feature that we're going to look at here is something called a Schomburgk pond. And this flat-lying area on the side of the drumlin here and on that side of the drumlin over there is something called a Schomburgk pond, or a clay plain. Now this formed at a completely different time during the Ice Age. Schomburgk ponds formed when the ice had retreated. It was several kilometers behind us. Water was flowing off of the glaciers, and it was getting trapped by a feature that you can see behind you on the horizon with windmills on it, called the Oak Ridges Moraine. So that actually prevented for quite some time water draining into Lake Ontario. So what we ended up with here is an area of drumlins that were essentially islands in a lake. And we had material that was being precipitated in those ponds. So if we think about the glaciofluvial environment that this material was being deposited in, the ice was a long way back, the water had melted, it had traveled down, it's not particularly moving fast, it's very still water. So what kind of particles do you think are going to precipitate out of very slow moving to still water? Are they going to be coarse or are they going to be fine?
Fine.
They're going to be really fine. Clay and silts are the only particle sizes that can actually remain in suspension in water that is not moving. So if we were to take an auger or a geoprobe or some kind of other tool to excavate into that paddock there, what we would see is a sequence of interbedded, layered silts and clays. And they are called varved clays. So is that an ice contact or a water contact feature?
Water.
It's a water contact feature. And it's formed distal from the front of the ice. So the ice is retreated, it's way back there. We are quite a long way from the front of the glacier. So, what kind of plants do you think would grow in that kind of environment?
Grasses.
Grasses, yep. You've got something that's pretty wet, remember? Is a clay-rich plain going to drain well, or is it going to drain poorly? It's going to drain pretty poorly. This one is actually well drained.